So now we will see a brief about it. So you must have noticed that when two similar kind of sounds are played together, sometimes the sound becomes loud and then soft, then loud again. Like there is a change in their loudness. So this rise and fall in the loudness is not random. This phenomena is called beats. So this is what called beats. So, for definition, we can say that beats are the periodic variation in loudness of sound heard when two sound waves of slightly different frequencies interfere with each other. Like when we hear two similar kind of sounds, we sometimes hear it loud, sometimes soft, and there is this periodic change in this. So, this is called beat. So, we can write it as beats are the periodic variations in loudness of sound heard when two sound waves of slightly different frequencies interfere with each other. So this is beats. So periodic means so don't be confused with this. And there must be slightly different frequencies. It is very important, the difference of frequencies. So these are the points you should remember. Most important is it is talking about loudness changes, not pitch. Now we will discuss why these beats occur. What is the reason behind it? So when two sound waves of nearly equal frequencies meet, sometimes they reach our ears in phase, like producing loud sound. Means when it will reach our ears in constructive interference, it will be loud sound, and when it will reach our phase in destructive interference, we perceive it as soft sound. So the constructive interference and destructive interference are those that we have studied in our previous lecture. So when there is a same phase, there is constructive interference, and opposite, then there is destructive interference. So this makes the sound louder or softer. So when two sound waves of nearly frequencies meet, sometimes they reach our ears in phase, producing loud sound, that is constructive interference. produce weak sound, or we can say soft sound, destructive interference. This alternate loud and weak sound is what we call beats. This alternate loud and weak sound is what we call beats. So there is this. Now we will talk about beat frequency. So what is beat frequency? It is the number of beats heard per second is equal to the difference of two frequencies. This is what beat frequency is. The number of beats heard per second is equal to the difference of the two frequencies. This is the beat frequency. The formula for this is number of beats per second. Formula for this is F1 minus F2. That is difference between two for the absolute value. And its unit is hertz. Since this is frequency difference, so unit of frequency is hertz. We denoted it like. Now let's solve a question on this. Question is two tuning forks are sounded together. One has a frequency of 500 hertz and there is 5 beats per second are heard. Now find the frequency of the other tuning fork. So can you solve it?
No, ma'am.
Frequency. What just happened? Okay. Can you see my screen?
Yes, ma'am.
frequency is 5. And second is frequency of 124. We can write it as 500 hertz. And we have formula for beats is f1 minus f2. And very important, there is modulus. Beats it is 5 is equals to f1 value is 500 hertz. We have to find out f2 with modulus. When we remove this modulus, we will put plus and minus sign for this. We know that inside value, if it is plus positive value, modulus will remove as it is. But if it is negative value, modulus will remove. We keep f to this side and 5 this side is equals to 500 minus 5. That 95 hertz left, and get that is 500. So these for both frequency will be possible. If that is frequency of the other one. We get two answers in this, and we because we do not know whether the unknown fork is at higher or a lower frequency. We don't know. It might be on the lower or might be on the higher. So we will accept both the answers. Both can be the frequency of fork. Are you there?
Yes, ma'am.
I can't understand whether you are. Now we will see stationary or standing waves. So our next topic is stationary. We also called it standing waves. So in this, when two identical waves travel in opposite direction with same speed and same frequency, they form a stationary waves. And why we called it a stationary wave? Because wave pattern does not move. Energy oscillates in this case but does not travel. That's why we call it stationary wave. So we can write when two identical waves travel in opposite direction with same speed and frequency, they form stationary waves. And in this case, wave pattern does not move. Wave pattern does not move. Energy oscillates but does not travel. It's like, let's say there is this string and there is two waves coming, identical waves traveling opposite direction. So one wave is like this and another, let's say, is like this, with same frequency, so it will go like this. So when we see both together, it will look like there is no change. There is the wave pattern does not exist, and in this case energy oscillates but it does not travel, like it is not traveling from here to here. Now there is two things. This we called it as node, and this we called it as antinode. So in this case, this node has zero displacement, and this antinode has maximum displacement. What is a node? We say that node is point where displacement is zero, and antinode point where displacement is maximum. And there is some important points, that distance between two nodes is lambda by 2. This is also node, this is also node, and we know that from here to here, this one complete circle is lambda wavelength, so the half of it is lambda by 2. So distance between two consecutive nodes is lambda by 2. Distance between two consecutive nodes is equals to lambda by 2, nodes or antinodes. In both the cases it is lambda by 2. Like if this is antinode, this is antinode, so it is also lambda by 2. And distance between node and the consecutive antinode, that is this and this distance is half of lambda by 2, that is lambda by 4. So distance between two consecutive between no need to write 2, between consecutive node and antinode is lambda by 4. So these are the important points. You should remember these points. Now we will talk about characteristics of musical sound. Characteristics of musical sound. There is different things for the characteristics of musical sound. Pitch, loudness, these are the things that we talk about, characteristics of musical sound. So first we will talk about pitch. So pitch, it depends on frequency. Pitch depends on frequency. Pitch is like when there is higher frequency, we say that it is of higher pitch. Like for example, the voice or the voice of a female has higher pitch than the voice of male. So it means the frequency of female voice is generally higher than the frequency of male. So it is means higher frequency means higher pitch. Second is loudness. Loudness depends on amplitude. When there is larger amplitude, that means louder sound. It depends on amplitude, that is lambda. Amplitude is the distance between the original position and the maximum height attained by that string point, we can say. So it is amplitude, not wavelength. Sorry for the confusion. Larger amplitude means louder sound. Okay, so loudness is subjective. Loudness can vary from person to person. Some person feel some sound a bit louder than the other person. So it is not absolute, it is subjective. Loudness is subjective, very important point. And intensity is objective, that how the intensity of the sound is objective. It is absolute, it cannot vary person to person. So these are the points that is necessary. So subjective means you can I told you that it is like depends on the listener, how sensitive the listener's ear is. And intensity is objective, that means it is the actual energy carried out by the sound per unit area. So it is an objective thing. So two people may feel same sound as loud or soft, but intensity remains same. So we can say that two people may feel the same sound as loud or soft, but the intensity remains same. Yeah. So now we will the chapter ended here, the theory part. Now we will solve some question, and then this chapter will be completed. the question 1 is transverse waves can be transmitted in A. Solid, B. Surface of liquid, C. Gases, D. A and B. So what is the correct answer? So for transverse wave, this transverse wave require rigidity. So solid has rigidity and liquid has also the rigidity, but this solid has rigidity, liquid surface also has rigidity, but gas does not have rigidity. So the correct answer is both A and B. Now go ahead with the next question, and next question is relation between phase difference and path difference is A. Theta is equals to 2 pi p upon lambda, B. P is equals to 2 pi lambda upon p, C. P is equals to 2 pi theta upon lambda, D. Theta is equals to 2 pi p upon lambda. Okay. Let's say this is both the examples same, just write it differently so that we can select only one. Okay. So phase difference is directly proportional to path difference. So here it is talking about what? Phase difference and path difference relation. So phase difference is directly proportional to path difference. And we write phase difference as theta and path difference as p. So we can say theta and p should be proportional, and there should be some constant when we convert it to equality. There should be some constant and p. So we will see option like in which case theta and p is directly proportional, and then we eliminate accordingly to choose. So first of all, this is the case of theta and p is proportional. So we can consider this one. In this case, there is no theta, so we cannot consider this one. In this case, there is p and theta in proportionality, so let's take it. Just for consideration, nothing else. In this case, theta and p is inversely proportional, so this is not. This is I am talking why I am eliminating this, to show you that how can you eliminate some options directly without thinking about too much. So from here we can remove these two options. Now we can play about what if A is the correct option or C the correct option with our memory, how much we remember, but at least we can remove some options with basic things. So what k value should be here is 2 pi by lambda p. So which is correct? 2 pi by lambda, option A. So our answer is option A. Now next question is velocity velocity of sound in air increases by with every 1 degree Celsius rise. Option A is 0.5 meter per second. Option B is 0.61 meter per second. Option C is 0.55 meter per second. Option D is 0.65 meter per second. Now we will solve it. So velocity of sound in air, we have to find out this. So find the formula for the velocity of sound is V is equals to 333 plus 0.61 t. So we put this value and see what changes it make for 1 degree. So we can see it is talking about increase. So let's say there is something, there is increase. Okay, so what is we can write that initially it is 333, v1 is equals to 0.61 t1. Okay, then v2 is 333 plus 0.62 t2. Now we have to find out the increase, only the increase. What is the increase means? Change. If I have 10 rupees and now I have 12, so when we talk about how much money increased, so we will say 2, that means there is change. So what we will find out? v2 minus v1. Let's say this is equation 1, this is equation 2. We will subtract 1 from 2, so v2 minus v1, and 333 plus 0.62 t2 minus 333 plus 0. Sorry, this is not 2, this is not 2, this is 1 0.61 t1. Now from 333 cancel out, and here 0.61 t2 minus t1, and this is the temperature change. And what is the temperature change? 1. So when we put 1 here, 0.61 into 1, it comes out to 0.61. So the correct answer is 0.61. Now next question is a tuning fork of unknown frequency gives 5 beats per second with 500 hertz fork. Options are 495. Okay, we have okay, just let's write it first, then we will discuss. 510. Option C is 500, 505. Option D is 495, 500. So it is asking about the unknown frequency gives by 5 beats per second with 500 hertz fork. So we just solved this question above. If you have remembered this question, this is the same question. Two tuning forks are sounded together. One has frequency 500 hertz and 5 beat per second are heard. Find the frequency of the other tuning fork. So we have solved it here, and the answer comes as 495, 505. Now you can go and watch this again if you don't remember, and try to understand from there. Now I will see the option. So option A is 495, 505. So this is the correct option. I am not writing it again because it is already in the video. You can watch it if you have any doubt. Okay, go ahead with the next question. So next question is point where amplitude is maximum but strain is minimum. Option A is nodes, B is antinodes, C is successive node, D is none. So the point where amplitude is maximum but strain is minimum. So where amplitude is maximum, it is talking about nodes, antinode and all this. So we know that if it is like this is node and this is antinode. So it is point where amplitude is maximum. So at node we know that amplitude is 0. At antinode this is the amplitude. So amplitude is maximum at antinode and strain is minimum. So at antinode particle vibrates with maximum amplitude and here strain is minimum. So the correct option is B. Now we go ahead with next questions. Question, a long answer type question. So first is write Newton's formula for velocity of sound in gas and explain Laplace correction. We have talked about it. I will write it again. So first it is asking about writing Newton's law formula. So Newton's law formula is is V is equals to root under P upon rho, where P is pressure and rho is density. In this case, Newton has assumed the process as isothermal. So that's why Newton's formula is not correct. So we have to write it that Newton assumed the process as isothermal process, which was incorrect. That's why Laplace corrected it. Incorrect. So there comes the Laplace correction. Laplace correction, that sound propagation occurs under adiabatic conditions because compression and rarefaction are very rapid. So that's why we cannot assume that it is isothermal. Here the correction comes and the corrected formula is gamma P upon rho, and the gamma is Cp upon Cv. So this formula, not this one, the upper one. So this formula give the correct velocity, gives correct velocity of sound. Now we will see next question. Derive equation of stationary wave and show relation between nodes and antinodes. Now we have to derive this. So in a stationary there is identical waves traveling in opposite direction. So we will assume two waves that is traveling in opposite direction. So let two identical waves travel in opposite direction. So one is y1 is sine omega t minus kx, and if I am taken at this, the other one is opposite, so we can write it as omega t plus kx. Now by superposition, if you have any doubt in the concept of superposition, refer to the chapter SHM and read it correctly and very thoroughly so that you understand these concepts. The SHM concepts are very important for wave, so go to it. So for by superposition we can write y1 plus y2. Now by using trigonometric identity, we can write as y is equals to 2a sine omega t cos kx. Now when this is our final equation, so in this we can see when cos kx is equals to 0, if this is 0, then this means displacement is 0, y will be 0, so this means displacement 0, it implies nodes. Second is when cos kx is equals to plus minus 1 implies maximum displacement maximum, so it implies antinodes. Hence we can say that nodes means 0 displacement and anti-nodes means maximum displacement. Now next is describe an experiment to demonstrate nodes and antinodes in organ pipe. So in this this is basically from practical classes. You can write it as like the apparatus required. Just a minute, there is some lagging. Yeah. Okay, so the apparatus required are organ pipe, tuning fork, water reservoir, there is some lagging. Something has happened. There is some kind of lagging is happening. I guess like this kind of question you can get in your textbook or in your lab classes. Um I can't write anything because of lagging, but I am just telling you what is you can write here. So for apparatus, you can write as I have mentioned organ pipe, tuning fork, and water reservoir. Then procedure, you will write procedure. So in this, the first step is fill the organ pipe partially with water. Then second step is strike tuning fork and place near the pipe. You will strike the tuning fork and then place it near the pipe. Then the third step is we have to adjust the water level slowly. Now the observation part comes in. In this, at certain position, sound is loud. Where so this point is antinode. We know the maximum amplitude is antinodes. So the positions where sound is loud is antinode, and the position where sound is weak is nodes. So these are the two observations. Then we will write in conclusion as nodes and antinodes are formed due to stationary waves in organ pipe. So these are the steps. First apparatus, then procedure, then observation, then conclusion. I can't write currently because of lagging, but I have told you all the things. If you can write it in your notebook with this audio, and if like you missed it, it is recorded, so you haven't had really a problem. You can rewatch it and then write it on your paper, and you can find it in your textbook also. So these are the steps, and here this chapter ends. Now we will next start the new chapter, probably the semiconductor. Yeah, okay.